An exoplanet is a planet outside our solar system. The first detection of an exoplanet that orbits a sun-like star was done in 1995 by Michel Mayor and Didier Queloz, who won the 2019 Physics Nobel Prize for their discovery. Over the past 30 years, nearly 6,000 exoplanets have been discovered. So, how was the first discovery made, and why are we looking for more exoplanets? I posed these questions to Professor Queloz, who was recently in Paris to deliver a lecture at Sorbonne University. Let's listen in.
Well, what we do to detect the first planet, well, we did actually, it was 30 years ago, to detect the first planet was to develop a new machine that is called a spectrograph that can measure very, very precisely the speed or the radial velocity of stars. And we detected a change in the radial velocity of stars with time. And this means practically that there is an orbiting object. And when we do the math, we realize that it is a planet mass object. So we claim the discovery of a planet mass object orbiting the star 51 Peg, with the slight caveats that the planet was within the mass of Jupiter, about the mass of Jupiter, but was on a much shorter period. It means the orbit was 20 times shorter or closer to the star than the orbit of the Earth.
Can you tell us more about this planet?
We don't know the size because there is no transit on that object. The system is not aligned to get a transit, but we know the mass. It's about half of the mass of Jupiter. I say about because the angle exactly of the orbit is not known and it produces some uncertainty. We know that the planet takes a bit more than 4 days to complete a full orbit. So think about a season that is 1 day. So this is what it is. Of course, because it's so close, the star is like the sun. So the temperature at the surface is more than 1,000 degrees. So it's really, really hot. I mean, it's kind of what we call a hot Jupiter. So it's like Jupiter, but the whole gas is brought to the very high temperature at the surface.
When and where did you make this extraordinary discovery?
So we discovered the first planet in 95. That was in Haute-Provence. This is the place where we installed this new equipment called LOD, that was able to measure very, very precisely the change of speed of the stars. And by detecting the change of speed, this is how we find out that there were a planet orbiting that star.
Can you tell us about the LOD spectrograph?
LOD spectrograph is a machine that compute a spectra, which means a rainbow. And we use this spectra to detect a change into the speed by using the Doppler effect. The challenge here is the change we wanted to detect is very, very tiny. And the equipment needed a complete brand new kind of technology. We had optical fibers, we had a new kind of optics called the grating, Echelle gratings, and we were the very first one to use intense computing methods to extract the signal from the data.
What role did the Haute-Provence Observatory in France play in your discovery?
So the Haute-Provence Observatory was critical because they really wanted an equipment of that kind. For them, it was part of a strategy. They wanted a high-resolution spectrograph. Michel Mayor wanted also one. He wanted to install one on another telescope, so they decided to team up and to design together one spectrograph and to produce two kits. One was LOD, the other one is actually Coralie, which has been installed 98 in a telescope in Chile. And you know, it's great because Coralie is still in operations in Chile right now, more than 30 years. There has been some update, but clearly this is kind of the same machinery. So I feel the very proud kind of father of two babies which are producing, keep producing, and some of them produce amazing science.
How do you look back at your discovery and what followed afterwards? The detection of nearly 6,000 exoplanets.
When I produced my PhD and you have to make a defense, I had the last slide in my defense, and the last slide was an iceberg. And I say, look, I think this planet is the tip of the iceberg. So I was expecting a lot more planets to show up. We picked the one which was easy to pick at that time, but it was clear that with such a weird object, there must have been plenty more. So I was predicting exactly what would happen. But frankly, I must admit the prediction went beyond my imagination because I never thought there would be so much diversity. And that for me, that's the main output of 30 years of discovery. It's not only that we started a program and we managed to stimulate the community into that, is there is so many planets in the universe which are different that we are completely changing the perspective on our solar system. And then we can ask the questions, why the solar system is like that? It looks so weird compared to the other we found.
What have we learned in the last 30 years?
Well, we learned that the solar system is clearly not a kind of the standard kind of planetary system you have in the galaxy. So most of the planets seems to be closer. They don't really sit in the way they are. And we know that the distributions of the small rocky planet and then the giant planet is one possible outcome of planetary formations. And they could have a lot of different ways and something between the Earth and Neptune, some kind of mini Neptune or super Earth or mini Jupiter or even super Jupiter. So there is a huge diversity in the planetary system, and that was essentially what we have learned in the last 30 years.
Why are we looking for exoplanets? What are we searching for?
You know, looking for planets is essentially looking for us. We want to understand the solar system. We have only one solar system. We look at the other system to understand how do we fit into the grand picture. So how do we fit in the grand picture, which is the galaxies and the universe? So understanding the many other planets would help us to understand ourselves and maybe ask the question, is the Earth a unique planet in the cosmos, or do we have plenty of other Earth? This is a question which is open because we have not answered that one specifically yet.
How many Earth-sized planets have been found so far?
We have no any discoveries that we can claim of a planet exactly like the Earth. We do have Earth size, we do have Earth mass, but most of these planets, they are much closer to the stars, or the stars is very different, like the TRAPPIST system. So they're not exactly the same. So let's say we have cousins. We found plenty of cousins, but we have not yet found a brother and a sister.
Is there a way of finding traces of life with the technologies we have?
I think there are hopes. Look at the Earth. We have so much oxygen on Earth. The only way to make it is to have life. So the idea that life, if life managed to develop fully on the planet, which is not a given. And when you look at the Earth, it took a long time to really be visible for life. I mean, to transform the atmosphere in such a way that it will become visible. But if you imagine life developing in a way that it will transform the atmosphere of a planet, I think yes, we can. We can detect the trace of life on planet by just looking at the atmosphere of this planet.
Are there any examples of Earth-like oxygen content?
No, we have not yet been able to do that because it's just the beginning. But we are finding the target right now. There is a new equipment called James Webb Space Telescope that get a little bit in that direction. We will have also the next generation of big telescope. One of them is extremely large telescopes, and of course there will be future generations of space missions that will also explore the solar system. Who knows? Maybe we're going to find life on Mars, even on Venus or Enceladus, Titan, Europa. All these systems in the solar system are interesting to look at, and we just have to go, bring back some sample, carefully protected, and study them carefully.